Hello, welcome. Let's try to solve another Leetcode problem. 2369. Check if there is a valid partition for the array. So let me just use the first example because this is really easy to explain. So definitely we have three different cases. So the first case is that we're gonna find the subarray. It's gonna consist of exactly 2. Yeah, so it's gonna consist of exactly 2 equal elements. So for example, 2 and 2 is going to be exactly 2 equal elements, and this 2 and 2 going to be a subarray, and this 4 and 4 and 4 going to be another subarray, but it's going to be 3 equal elements. So this is going to be the second case. And the third case is that it's going to have the increasing subarray. So the consecutive increasing elements, so it's going to be like 3, 4, and 5. So it must be consecutive increasing elements. So 3, 4, 5 is good, and 1, 3, 5 is not. So let's just use the first example to find a solution to solve the problem. As we definitely have 3 different divisions, so let's just try to use the first method. So we're gonna first find the 2 equal elements. So we're gonna find 4 and 4. So what left behind is 4, 5, and 6. Now let's just check 4, 5, and 6. Is that possible? Yes, because this is 3 consecutive elements. So this is going to be a true case. Now let's just check the second case. Maybe we're going to find 4 and 4 and 4. So this is going to be the second case. We find 3 equal elements. Now what left behind is 5 and 6. But is this possible? So this is not possible. So this is going to be a false. So we just want to find if there's a true, so we're going to return true. So we don't care how many falses, we just need to care if there's one splitting of true, so we're going to return a true. So we're going to return true if the array has at least one valid partition. Otherwise, we're going to return false. So this kind of problem, we're going to call it a partition problem. Definitely, we're going to partition the array into different parts. And if it is okay, we're going to return true. Otherwise, we cannot find the partition, so we're going to return a false. I think the easiest way is going to be cas with DFS. So we're going to use the cas and the DFS to solve the problem. So I'm going to study the index from 0. So finally, I'm going to return this DFS starting from index 0. So I want to check the index. So if the index is equal to n, so this n is going to be the length of the nums. So let me just prepare the length of the nums. So if I equal to n, so I'm sure it's going to be true. So otherwise, I'm going to prepare 2 different cases. It's going to be result 1, result 2, and normally it should be 3 different cases, but we can combine them to 2 different cases because for one part, the length is going to be 2. Another part, the length is going to be 3. Because the second case, the length of the subarray is going to be 3, and the third case, the length of the subarray is going to be 3. So the second and third case can combine to one case. So we just need to prepare 2 cases, result 1 and result 2. So we're going to set it to be false from the beginning. So finally, we just need to return result 1 or result 2. So this means if there's a possible solution, so we're going to return true. Yeah. So this is the basic idea. Now let's just check result 1 and result 2. So for the result 1, we need to check for I plus, we need to check if I plus 1 is less than the length of the array, and nums I equal to nums I plus 1. So this means it is a possible split. So we're going to record the result 1, so it's going to be equal to the DFS with I plus 2. So this is going to be the first case. And then let's just check the second case. It's going to be I plus 2 less than n, and we're going to check if this one equal or not, but the length is going to be 3. So if nums I equal to nums I plus 1 equals to nums I plus 2, or we need to check another case. So another case is that nums I plus 1 equal to nums I plus 1, and nums I plus 1 plus a 1 equal to nums I plus 2. So this is going to be the second case, but we're gonna combine them together. Yeah. So if either one of them is true, if this one is true or this one is true, so definitely we're gonna get the second case. So the result 2 gonna be DFS I plus 3. So for the final return, we're gonna return result 1 or result 2. So this means for the splitting, yeah, so we're gonna use this example. We're gonna use this kind of splitting. If this is true, we're gonna return a true, or we're gonna use the second splitting. If this is true, so we're gonna return a true. So this is gonna be the solution. So let me just run it to check. Unexpected in that. Let me check what is wrong with the case. Now let me just run it. Yeah, so there's something wrong with the index of the Python. Let me just check. Oh, here I did a typo. Let me just run it. Now as you can see it works, and let me just submit it. Yeah, as you can see it passed all testing cases, and it's pretty fast. And this is going to be an ON solution because we used the cache. Thank you for watching. See you next time.